All right, this is our factoring review to be done after the 5152 notes. I'm going to skip over this. Second slide is multiplying binomials. You guys multiplied binomials in your summer work, so hopefully you are good to show the work, and you certainly don't need to, but you would make sure that you are distributing each term in the first binomial to each term in the second binomial. So x squared plus 4x negative 4x minus 16. So x squared minus 16. Now that being said, you don't need to show all those steps out. Just more a matter of make sure that you are distributing to both terms and not just distributing the x to the x and the negative 4 to the 4. So my next one here would be b squared minus b minus 42. My binomial squared, a squared plus 10a plus 25. 2x squared plus x minus 15. And last but not least, negative 6x squared minus 4x minus 20. So hopefully that is good to go for you. No issues there. Now, when we talk about factoring, there's a few different ways that we can approach this. The first thing that we can look at is common factoring. So factoring out a greatest common factor of a binomial, a trinomial, whatever the polynomial is. So for the first one, we have x squared minus 3x. I can factor x out of both terms. So I'd be left with x times x minus 3. The next one here, I have an x in each of these terms, so I can factor an x. I'm left with 2x squared minus 3x plus 1. Now we'll talk about that trinomial in just a second, but starting with the GCF. So my recommendation is always look for a GCF before you do anything else. Remember that if you're going to factor out a common factor, each term in the polynomial has to contain that factor. Next one, I can factor out a 4, 2x minus 1. Next, I can factor out a negative 1, so I'm left with x squared plus 3x plus 4. Same thing for my next option. I have a negative 1 that I can factor out, x squared plus x minus 12. And then the last of these common factoring, there's both a constant and a variable that I can factor out. So I'm left with 5x minus 1. So make sure that you are looking for common factors first. That's the first thing you want to look for before you worry about factoring anything else. Now, if you look here, factoring trinomials, which is the opposite of foiling or the opposite of distributing. So what you're looking for is the two binomials that were multiplied to give you the trinomial that you have. I think the biggest thing that you want to make sure is that you are getting that middle term correct. So if you have an x squared, well, guess what? The only two terms you can multiply to get that are x and x. Now my C term is 5. In this situation, 5 and 1, that's it. Those are my only factors of 5, so 5 times 1 is 5. Since this third term is positive, you either multiplied two positives or two negatives to end up with a positive product. In this case, since the middle term is positive, these guys both had to be positive as well. If I look here at the next one, x squared, so again, the only terms that I can multiply to get x squared are x and x. Now if I look at this 5, again, 5 and 1. Now if you look, it's a negative 5. So negative 5 means that I had to have a positive and a negative sign in order to have a negative product. Since my middle term is positive, that means that the bigger guy had to be positive. and the smaller factor had to be negative. Remember, you can always check your factoring, make sure that it's correct by doing that distributive property. X squared minus x plus 5x minus 5, x squared plus 4x minus 5. So you can check these as you go by doing that distributive property. So I would say, take a few minutes, make sure that you're okay here with factoring with a leading coefficient of 1. These guys tend to be the easier ones because really all you need to think about is, products of C, or the product which is C, and then those factors that add to B. So x plus 5, x plus 2. X, whoopsie, x plus 5, x minus 2. Here I have x minus 5, x minus 1. Now take a look at, these first two here, just something to draw your attention to, that both have 5 and 2 as the factors. It's the signs that are different. So they both have the same C value of 10, but since the C's have different signs, positive and negative, it tells me that the factors have to have different signs. So in the first example, both positive or both negative, and in the second example, one positive, one negative. If the middle term is positive, just some things to keep in mind, then the larger factor has to be positive. If the factors are different signs, if they're both positive, then fine. If they're both negative, then fine. So my next one here, if I'm looking at x squared minus x minus 20, so x minus 5, x plus 4, so that's an example of, okay, so I have a negative 20, so that means that my factors had to have opposite signs. Since my middle term is negative, the larger of the two factors had to be negative.
Forever, Mark. A diamond is forever.
X minus 6, x minus 2. So this was a positive 12, so it means that I had to have either both positive or both negative for my factors. Middle term is negative, so both my factors had to be negative as well. Now, if you look at this last one, change to vertex form and graph, so that was sort of just a continuation of the lesson that we did, 5.1.5.2. So if I look, I'm just going to put this down here so you can see it a little better. Y plus 9, x squared minus 8x. Remember that to rewrite this in vertex form, we want to complete the square. To complete the square, you're going to add b over 2 squared to both sides. So negative 8 over 2 is negative 4 squared is 16. 16. So y plus 25 equals x minus 4 squared. So now I made this jump here. If you look at what we've been doing, when you have x squared minus 8x plus 16, 16 is the product. So the factors of 16 whose sum is negative 8. Negative 4 times negative 4 is positive 16. Negative 4 plus negative 4 would give me negative 8. And now if I'm going to graph, so my vertex is at 4, negative 25. Now I have minus 9 is my C value, so that would be my y-intercept. And then remember that you have that symmetric point, so we'll say this is my 8 here. And there is my sketch. Now, when you're looking at problems with a leading coefficient, which is what you're seeing here, so 8x squared plus 10x minus 3, etc. There's a few different ways that you can do this. I'll show you the way that I'm most comfortable. I will show you the way that Miss Coates is a little bit more comfortable. And then it's really kind of just up to you guys as to what you... So when I'm looking at 8x squared plus 10x minus 3, this is the way that I handle these problems. Let me scroll here a little. All right. So if I look here, 8x squared plus 10x minus 3. So this is my process. And again, like I said, this is what works best for me. I know that when I was factoring, way back when I was in high school, I was very stressed out by guessing and checking, which other teachers feel more comfortable with. So it's really just kind of whatever works best for you. So here I go. 8 times negative 3 is negative 24. So I'm finding the product of A times C. And then what I'm going to do is I'm going to list my factors of negative 24 to try and find the factors whose sum is this middle term. So if I go through, 4 and 6 may be something that pops into your head, but since it's a negative 24, it means one has to be positive and one negative. If you have opposite signs, they're not going to add to give you that 10. So instead, 12 and negative 2 would give me product of 12 and negative 2 is negative 24, that A times C, and then the sum is my B. So now I basically am going to just split the middle. 8x squared plus 12x minus 2x minus 3. So if you look, my positive 10x is equal to 12x minus 2x. So I'm just rewriting that middle term. So now I'm going to factor out a GCF on the left and the right. 8x squared plus 12x, GCF is 4x. I'm left with 2x plus 3. On the right, GCF is negative 1. When I factor that out, I'm left with 2x plus 3. That should always happen. Those factors that are in the parentheses should be the same. So now you're looking at the left and the right. They have a GCF, 2x plus 3. So if I factor that out of both sides, and then 4x minus 1 is the other factor. It's what's left when I factor out a GCF. Okay? So now if I look at, let me just get rid of this so I have some space to work here. So if I look at the next one, 7x minus 5x minus 12. I'm sorry, 7x squared minus 5x minus 12. So the guess and check method, which a lot of people feel more comfortable with, goes something like this. So your 7x squared is your first term. The only way that I can get 7x squared is if I multiplied 7x and x. Now I look at my negative 12. So my factors of negative 12 would be 1 and 12, negative 1 and 12, sorry, 1 and negative 12. Negative 2 and 6, 2 and negative 6. Negative 3 and 4, 3 and negative 4. And so basically what I'm doing is trying to figure out which of those should go into these missing spots so that if I were to distribute, I would have a negative 5. So if I were to try, I'm going to say, if I try this first one, negative 1 and 12, so minus 1 plus 12. So now if I were to distribute here 7x times 12 and then negative 1 times x, that's absurd. That doesn't work at all. So instead, I'm going to try swapping. And I'm going to write 12 here and 1 here. So now if I look, I have negative 12x, yep. And then 7x, negative 12x plus 7x is negative 5. So there is my result. And now, my only concern, issue, whatever with this method is if you don't get the right factors in your first try, then it certainly is going to take you a little bit longer. Now, that doesn't mean that you can't do it that way, but you are going to have to make sure that you check, basically really focusing on that outside inside, to get that middle term more than anything. So let me do some of these other ones with you. Okay, so what is it? 3x squared minus 10x plus 8. Now again, my method, 3 times 8 would be 24. Factors of positive 24 whose sum is negative 10 would be negative 6 and negative 4. 3x squared minus 6x minus 4x plus 8. On the left, my GCF is 3x. I'm left with x minus 2. On the right, my GCF is negative 4. I'm left with x minus 2. X minus 2. 3x minus 4. My next example is 5x squared minus 8x minus 4. Again, if I use the guess and check method, 5x squared, so I know it's going to be 5x and x. So now negative 4, my factors are 1 and negative 4, negative 1 and 4, 2 and negative 2. So if I go plus 1 minus 4, negative 20 plus 1 is not going to work. If now I say, okay, find 5x minus 4, x plus 1. So now if I do 5x and 1 is 5x minus 4x, that would just be x. So that doesn't work. 5x plus 2. 5, oops, sorry. X minus 2. So I have negative 10 plus 2 would give me negative 8. So I'm good. All right, my next example. Let's see. Sorry, I lost it. 9x squared minus 11x plus 2. Again, if we go with my method, 18 factors, negative 9, negative 2, would give me negative 11. 9x squared minus 9x minus 2x plus 2. GCF is 9x. I'm left. All right, so now if I look here, y equals 2x squared plus 7x plus 6. If I want to rewrite that in vertex form so that I can sketch a graph, I'm going to start by subtracting 6 from both sides. I'm left with 2x squared plus 7x. Now remember that what I do is I need to start by factoring out the leading coefficient here, which is 2. I'm left with x squared plus 7 halves x. I'm going to add b divided by 2 squared, so 7 halves divided by 2 would be 7 fourths. Squared would be 49 sixteenths. Make sure that my math is correct. Hold on, let me just think of that quick. 7 halves divided by 2. Yes, squared, good. Now if I were to distribute the 2, because remember that's what you have to add to the left-hand side, it would be minus 6 plus 49 eighths, x plus 7 fourths squared over here. So let's see, this would be 48. So y plus 1/8 equals to x plus 7 fourths squared. My vertex is at negative 7 fourths, negative 1/8. If you look up here, my C is my y-intercept, so I have a y-intercept at 0, 6. So I have a symmetric point at 6, negative, so it would be negative, my brain's broken, so 1 3/4, 2.5. Is that right? I don't even know. I can't even think right now. That'd be on the other side. 1 3/4 and then another 1 3/4. I'm going to go with negative 3.5 because really that's the best I can do. Bear with me. I'm sleepy. All right, now when I look here at this slide, the reason I bring this up is that these guys are the special factoring. So these are perfect square trinomials. What is a perfect square trinomial? It's basically a trinomial that is created or, is the result of squaring a binomial. One way that I can tell is that my first and last terms are both perfect squares. Now, you can't just automatically assume then that it's a perfect square trinomial, but it's a pretty good indication that it will be. So if you have that three terms, x, square root would be 2. So now you can check to make sure that that is legit, obviously, by squaring that or multiplying. So x and 2, so 2x and 2x is 4x. That does equal that middle term. Good to go. If I look here, square root of 9x squared would be 3x. Square root of 16 would be 4. So now again, if you were to check your work, 3x plus 4, 3x plus 4, 12x, 12x would be positive 24. So I know that that checks out. Perfect. Now the only difference here with this guy, because my middle term is negative, what I have to do is 7x minus 6 squared, 7x minus 6, 7x minus 6, negative 42x minus 42x is negative 84, so yay, that works. Now when I look here, change to vertex form and graph, if I look, I have x squared and a positive 25, x minus 5 squared. Vertex 5, 0, 0, 25 is my y-intercept, 10, 25 is that symmetric point. Now on this slide is the other special factoring, and that is the factors that come as a result of the difference of squares. Now notice I said the difference of squares. This only works as if you have two perfect squares separated by a minus sign. That is always the result of the difference of the two binomials. I'm sorry, that's not what I meant to say. That's always the result of multiplying two binomials with opposite signs. 10x squared minus 1, so it would be 10x plus 1, 10x minus 1. And when you look at my next one, 64x squared minus 81, both of those are perfect squares separated by a minus, so that's good. So I have 8x minus 9 or plus 9, doesn't matter which one goes first. And then if I look here, I have y equals. Now, in order to complete the square here, this has to be a perfect square trinomial, but my issue is this, I don't have a b term. So what I want to do is just, hold on, bring my 25 over. So I actually don't have any work to do here. It's 0, negative 25. That is also my y-intercept. So from there, I would need to think about my x-intercepts, which come from the factors. So remember that x-intercepts happen when y is 0. So if this is equal to 0, then one of two things had to happen. X was either negative 5 or positive 5. Those are my x-intercepts. just sort of summarize here with you. So the two things that you want to look for is a perfect square trinomial. So, hold on one second. X plus a squared. If I were to multiply that or square that binomial, I'd have x squared plus 2ax plus a squared. So as you're working and you're looking at these trinomials that you're being asked to factor, you're looking for that format and working back. Now, if you had x plus a, x minus a, if I were to multiply that, I'd get x squared minus a squared. Again, if you're looking at a binomial in that format, work backwards for your factoring. Hope this helps. Remember what I said, factoring is so important, definitely something that you have to be able to do and do well. So practice, there's plenty of practice sheets on there for you. So keep plugging away at it and let me know if you need any help.